10-5. This is going to be our last section of the year, so congratulations on making it. The last section is going over something called permutations and combinations, which, if I'm being honest, when I was in high school, I completely failed this section. But after failing it the first time, I figured out what the whole thing was about. And so I'm going to share with you some tricks that I picked up over my experience with dealing with permutations and combinations. And hopefully you will not fail this section because you have somebody who is helping you and has been there and done that. Don't fail, it sucks. Okay, so the first word you have to understand is factorial. Factorial is given by an exclamation point. When you see the exclamation point, all you're going to do is you're going to take that number and then go all the way down until 1 and multiply those numbers. So, for example, if we had 4 factorial, that's how you would say that, it would be 4 times 3 times 2 times 1, which if you multiply into your calculator, it's going to give you 24, okay? Even if you have something really big, you can do, let's say 12 factorial. It would be 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and that would equal 479,001,600. That would be our answer, okay? So just make sure that when you're doing this, you are being very careful on how you're multiplying, but also know that your calculator typically can just calculate this for you. If you're using the TI-84 Plus, then all you would have to do is click on Math, go over, press the arrow button until you get to Prob, and then if you look at your list from there, number 4 is an exclamation point. So you don't even have to do 12 times 11 times 10 all the way to 1. You can just type 12 and then go to that prob area, that probability area, and click the exclamation point, and it'll calculate it for you. If you don't have a TI-84, then you can go to the internet. There are plenty of factorial calculators out there. I strongly recommend it. I think other calculators will allow you to do it too. I'm pretty sure the Casio will let you. And I know for sure that the TI-30XS, that one also allows you to use factorials. You just have to find it. So if you have any questions, typically the best thing you can do if you have a question of how to use your calculator is go to Google. Type in the type of calculator you have, which is usually listed at the very top of the calculator, and then follow it up with how to, and then factorial. And it should either give you step-by-step instructions or it'll give you a video, which I know a lot of you guys really like videos, especially after 3 months of online school. I'm sure you guys love videos now. Anyway, so the next piece is our permutation. So the whole purpose of knowing what a factorial is so that we can actually use it in our permutations. So permutations are where order is important, okay? This can be anything, okay? Just make sure order is important. So in this particular case, our formula for permutations, before I move on though, I do want to tell you that factorials, there's one thing you should know, and that is if you ever see a 0 factorial, that is going to be equal to 1, okay? So make sure you know that and have that sort of in the back of your mind. That's very important. Okay, so now let's go to permutations, where order is important. And the formula you need to know is this, okay? Just know that if you are using all of your items, okay, it's just the same thing as the factorial. But let's say you don't want to use all your items, and I'll explain this in a second. Let's say we don't want to use all of our items. Well, then that means, we have our total in front, and then the pieces we're pulling out. The formula would be this. Okay, and just so you guys are aware, N represents our total number of items, and our R represents the number of items we are using, okay? So in example 1.1, I'm just going to start off with the first formula of permutations because it's basically the factorial. We have the question, how many ways can we rearrange the letters in the word July? Okay, so in this particular case, I have 4 total letters, And it doesn't specify how many letters I'm rearranging. It just says all the letters. So my R is going to be 4 as well. So then I can plug into the formula. 4 permutation 4. And I think this is said to be a permutation of 4 using 4 items, okay, or pulling 4 at a time. I just say 4 permutation 4, but that's wrong. But anyway, that'll be 4 factorial, which we've done before, and it's going to be 12. Okay? Or, I'm sorry, not 12, 24. 24. My bad. Not 12, 24. I really want to put 12. Okay, 24. All right, and then the next one says, well, how many ways can we rearrange the letters in the word house? So that word house, we have 5 letters, 1, 2, 3, 4, 5, and R is going to be, again, 5, because it doesn't specify how many we need to pull out. It just says how many ways can we rearrange all the letters. So 5 permutation 5 is going to equal to 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is going to be 120. So in part B, we have the same word. How many ways can we rearrange 2 of the letters in the word July? So again, we're going to have a total number of items being 4, because we have 4 letters here. And then we have the specification of 2 letters being used. So that's going to be our R. And so we plug it into the formula, 4 permutation 2. And so if we plug in the formula from here, it should be 4 factorial over 4 minus 2 factorial. Okay, and so this is going to equal 4 factorial over 2 factorial, and if I were to expand this, it would be 4 times 3 times 2 times 1 over 2 times 1. I can cross out the 1 and the 2, and then I'm just left with 4 times 3, so my answer would just be 12. All right. Then over here I have how many ways can we rearrange 2 letters in the word pencils. All right, so first thing we need to do is figure out what is our total. So we have n equals, and we got 1, 2, 3, 4, 5, 6, 7, and we need to pull 2. So our R is going to equal 2. Plugged into the formula for 7 permutation of 2 is equal to 42. And this time I used a calculator because, after you do this so many times, you start getting used to the process, and really I strongly just recommend using your calculator every time because it is just really accurate and reliable. So in example 2.1, now instead of working with like letters, we're working with real life scenarios. And so this says we have 10 horses are running in a race. How many ways can the horses finish first, second, and third? So I have to ask myself, is order important? Well, yeah, it is important. The first horse that passes the finish line is going to be first, and it's not like the last horse is going to be first. That's not how that works. Okay, so order in this particular case is important. And anytime you see first, second, or third, you always need to use permutations. So I would say that my total is 10 horses. That's my total. And my first, second, or third, that is 3 spots, so that's going to be my R. And so I would say 10 permutation of 3. If I use my calculator, it'll give me 720 possibilities. So if I have 10 horses, how many combinations could I have for first, second, and third? I can have 720 different possibilities. All right. Even over here in example 2.2, it says 8 people serve on a committee. How many ways can a chairperson, a recorder, and a treasurer be chosen? So because they specified the types of jobs, the order is going to matter. The responsibility of a chairperson is different than the responsibility of a treasurer, okay? So because I have a difference in the responsibilities or a difference in the ranks, then this is going to be a permutation. So I would say, all right, my total is 8, and I have a chairperson, a recorder, and a treasurer, so that's going to be my R. So I would say 8 PR is equal to, and I use my calculator, 336 possibilities. All right, the letter B's for example 2.1 and 2.2. The 2.1 says a student council has 15 members. How many ways can a president, vice president, secretary, and treasurer be picked? Okay, so they specified the type of jobs, okay? The jobs between the president and the secretary are very different. So I know that order in this particular case matters. So I know I'm going to be using a permutation. So I have a total of 15 people, and I have president, vice president, secretary, and treasurer. So I have 4 different types of jobs or ranks that I need to consider. So this would be 15 permutation 4, and then I could plug into the calculator. I could plug it into the formula or the calculator. I recommend the calculator. It should give me 32,760 possibilities. Example 2.2b says 100 people enter in a raffle. How many ways can a person be drawn to win $100, $50, and $20? Okay, so in this one, order matters again because the prizes that were being given is different. Okay, if I were just getting the same $5 Starbucks gift card no matter what, well then order would not matter. But in this particular case, $100 is very different than $20. So I know that the order of being picked is significant. It is important. And so I'm going to use a permutation. 100 people is my total. I have prizes of 100, 50, and 20. So that's 3 possibilities there. And so I would say 100 permutation 3 and use the calculator to get 970,200 people. So now example 3 is just going into the next step, which is using the permutation and combinations to find probability. When we did this in the previous sections, we would have to either create a table or we would have to create a tree in order to do this. But now that we have combinations and permutations, we can actually make our life a little bit easier and not have to draw all of the possibilities. We can just use the permutations to help us figure this out. So example 3.1 says, for a town parade, you will ride on a float with your team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. So the first thing we should do is just sort of visualize what this probability is going to be. We know that the probability is going to be your team and then the choir or the chorus. And that's going to be over all of the possibilities. All of the possibilities. So if we have all possibilities, well, there's 12 floats in total, so that would be 12 permutation 12. Okay? And since your team and the choir are sort of already decided, if you will, what we have to figure out for the numerator is what is left. And if you think about it, there's 12 floats. We subtract your float and the choir's float, and that leaves 10 left over. And they don't say anything about the order for the for those 10, so we would say 10. Okay, so there's 10 spots left. So it would be 10 permutation 10. Okay, because we don't care what order they have, as long as your team comes first and then the choir. So we can put this in a fraction, which, gives us our probability. This would end up being 10 factorial, over 12 factorial. And I'm going to rewrite this a little bit. I could use my calculator, but I just want to show you what would go behind it in case you don't have a calculator. It would be 10 factorial over, and I'm going to expand the 12 factorial for a second. I'm going to do all the way to 10 because then I would have the same thing. So it would be 12 times 11 times 10 factorial. Okay? So anything that is the same in the numerator and the denominator when you're multiplying can cross out. So the 10s will cross out along with their factorial. Because think about it, it's 10 times 9 times 8 times 7. And below you have 10 times 9 times 8 times 7. So it's going to be the same thing. So we can cross out both items. That means I'm left with 1 over 12 times 11, which is going to equal 1 over 132. If I plug this into my calculator, I will end up getting 0.008 or 0.8%, and this is going to be my answer. And again, you do not have to always put the fraction, the decimal, and the percentage. I am just showing you all the possibilities because the homework and the quizzes and the test, they may ask you for one of the three. So that's why we practice all of them, just to make sure that no matter what they ask, you know how to get to the others. Example 3.2 says Andrew and Brian are auditioning for a part in the school play. There are 15 people auditioning, and the order of their auditions is chosen at random. Find the probability that Andrew auditions last and Brian auditions second to last. So those positions are already determined. So we would say the probability of Andrew being last and Brian being second to last over the all of their possibilities. Okay, so we would do the same process as we did in 3.1. So we would say that if there are 2 spots already taken, well, 15 minus 2 is 13. So that would be 13 factorial over all of it, which is 15 factorial. So again, I'm going to expand out 15 for a second. 15, 14, 13. This cancels out with this, and I'm left with 1 over 15 times 14, which if I plug in my calculator will be 1 over 210. If I wanted to find my decimal, it would be 0.005 or 0.5%. So I went ahead and just skipped the little pieces of notes at the top of example 4, just because it would have taken extra time and I didn't feel like doing that. But I am going to tell you what that formula is that you do need to put in there. The variables mean the exact same thing, but you are going to have NCR is going to be equal to n factorial over n minus r factorial, r factorial. And so this is representing our combinations. And combinations is when order does not matter, okay? Things, and as we look at these examples, you'll see what I mean by the order does not matter. So in 4.1a, it says how many combinations can be made from drawing 2 letters from A, B, C, and D. So in this particular scenario, beforehand we had a word and we were rearranging the letters. Okay, so obviously order is important. But this one is, well, we don't really care about the order. We just care about pulling 2 of the letters. And it doesn't specify anything. It actually uses the word combination. So we know we have to use combination here. So we would say, all right, our total is going to be 4. And our R, what we're pulling, are 2 letters. And so I say that total is 4 because we have A, B, C, and D. Those are 4 options. So this would be 4CR, C2, excuse me. And if we use the formula, and I'm only going to use the formula for the first one, after that I'm going to use my calculator, it'll be 4 factorial over 4 minus 2 factorial times 2 factorial. And so the numerator stays the same. My denominator reduces to 2 factorial times 2 factorial. And so this is going to end up equaling 4 times 2, or 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. All right, now I can cross out things that are the same. I got 1 in the top and 2 in the top and bottom, which I can cross out. And so I'm left with 4 times 3, which is 12, over 2 times 1, which is 2. And 12 divided by 2 is obviously 6, so that is our answer. Next to that, it says you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8, and how many combos are possible. Again, it doesn't matter if you get mac and cheese and green beans, or green beans and then mac and cheese. It doesn't really matter which order you order your side dishes in, okay? So order does not matter. It's just food. So we would say our total is 8, and our R is going to be 2. So we plug it into the formula or plug it into our calculator and get 28 options. 4.1b says your Spotify playlist has 16 songs, but you only have time to listen to 3. It doesn't specify which order you need to listen to these songs to. So obviously this is going to be a combination. We would say 16, combination 3, plug it into the calculator for an option or a total of 560 combinations. Letter B, 100 people enter in a drawing for 5 possible Publix gift cards, $25 a piece. how many combinations are possible. Okay, so again, we have the same gift every time if you are drawn for this rally or this raffle. So in this case, order doesn't matter. The prize is exactly the same no matter which order you're called in. So because the prizes are all the same, this is going to be a combination. It'll be 100 combination 5. Plug in the calculator and you get 75,287,520 combinations. 4.1c says you need a subcommittee, and I forgot to write it on this one, but you'll see it whenever you download it. It says you need a subcommittee of 5 students from student council to represent the juniors. If you have 40 members, how many combos could create the subcommittee? Okay, so the subcommittee doesn't have any ranks. It doesn't have a president, a vice president, a treasurer. It doesn't have anything like that. It's just you're part of a group. No rank, you're all equal, you're just part of a group. And so because there's no ranking, this is going to be a combination. We'll say it's 40. So this is the statement that you need. But we would say it's 40 combination 5, and use a calculator to get 658,008 people, or 8 combinations. The one next to it says you need 4 photos on a yearbook page, and you took a total of 106 photos. How many combinations are possible? Again, it doesn't specify this time that we need a certain picture at the top or a certain picture at the bottom. It doesn't specify anything like that. So because there are no specifications, order does not matter. You just need 4 good photos. So you would say 106 combined with 4. Use the calculator to get 4,967,690 possibilities. So now we'll do some probability with combinations. Example 5.1 says a yearbook editor has selected 14 photos, including one of you and one of your friends, to use in a collage. The photos are placed at random by 2s. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? All right, so this one we would say, what is the probability of you and your friend being at the top? And with this, order doesn't matter at all, okay? So it doesn't matter if you're on the left and she's on the right or vice versa. That doesn't matter. So with this, we can figure out how many possibilities that is, which is only one possibility because it could be just you and her or you and him, whatever it is. And it can't be like you and some other random person. That's not how it works. So you only have one possibility for this. So we'll write that in a second. We'll say this is over all the possibilities. Okay, so we said that there's only one possibility or one possibility for our numerator. All right, and for our denominator, notice how it says the photos are placed at random by 2s. So again, when we do this, it's going to be 14C, because it's combination, order doesn't matter, 14C, and then 2. 14C2, because we have a total of 14 photos, and they're pulling 2 at a time, all right? So this is going to be 1 over 14C over 2, which is the same thing as 1 over 91. If I plug this in my calculator, it's going to be approximately 0.11 or 1.1%. 5.2 says the art teacher has selected 13 projects, including you and your friend, to use in an art walk. The projects are placed at random, but what is the probability that your project and your friends are the 2 placed in the middle? All right, so again, we can create our probability. We can say the probability of you and your friend in the middle over all of the possibilities. Okay, so you and your friend, there's only one possibility here, or one scenario. And then out of all the possibilities, notice how in this particular case we have a total of 13. Okay, we have a total of 13, and it doesn't specify that we're pulling 2 or 3 or anything like that. So we're left with whatever we haven't used. Well, in this case, we used yours and a friend. So that's 2 that are no longer viable to be pulled. So 13 minus 2 is going to be 11. So we would say this denominator is slightly different than the other example. It'll be 13C 11. All right, so our probability be 1 over 13C 11, which is 1 over 78. And this is approximately 0.013 or 1.3%. Example 6 is all about food, so this will be fun. Example 6.1 says nacho taco has 2 main ingredients and 3 toppings for a meal. How many different burritos are possible? And it gives you a menu below. So the first thing we need to do is sort of like think this one through. We know that we have main ingredients and we have toppings. And so these possibilities, okay, main ingredients and toppings, this is going back a little bit to I think it was 10-3, where we talked about multiplying. So the word and means multiplication. So we could say that this is the main times the toppings. All right. And now we need to figure out, well, what is the number of possibilities for the main ingredients and what is the number of possibilities for the toppings? So in this particular case, order does not matter. Food is food. Okay. It doesn't matter if you put ham and cheese or cheese and ham. It doesn't matter. Order does not matter when it comes to food. Plus, it's delicious. So we are going to figure out from this piece what our number of possibilities for the main ingredients are. We know that we can pull 2, but we need to know what is the total, and that's where the menu comes into play. So I would say that this is going to be, if we count it, we got 1, 2, 3, 4, 5, 6, okay? So we have a total of 6 ingredients that we could possibly use. Again, order doesn't matter, and we need 2. So it'd be 6C 2, all right? And then we're going to multiply that with our toppings. Okay, so we need to count our toppings. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a total of 8. And again, in our instructions, it says that we need to have, or we can have 3 toppings. So it'd be 8C 3. 6C2 is going to equal 15. Carry down that multiplication symbol. And then 8C3 is going to be 56. So I could have a total of 840 different possibilities for my burrito. There's 840 different variations. All right, 6.2, same idea. We have 5-star pizza. I love 5-star pizza. If you have a chance to go to Edgewood and have 5-star pizza, I strongly recommend it. But they have 2 different crusts and 2 or 3 different sauces, 5 different toppings. And if a standard pizza has 1 crust, 1 sauce, and 2 toppings, then how many different pizzas are possible? All right, so again, we're going to take the different types and multiply them together. We got our crust, our sauce, and our toppings. Okay, then we are going to figure out our combinations. Okay, we have 2 different total crust styles, and we can only have 1. So 2, I'm carrying out the multiplication. This would be 2C1. The sauce would be 3C1, all right? And our toppings would be 5C2, okay? 2C1 is going to equal 2, 3C1 is 3, and 5C2 is 10. So if you multiply all that, 2 times 3 is 6, and 6 times 10 is 60. That is our answer. So just a little bit of review. Just want to make sure we have this down. When we are talking about permutations, permutation is when order matters. It matters so much. Please make sure that if you know the order matters, you're using permutation. Now, what are some key words or key things that help you know it's going to be permutation? Well, that means you will see things like first, or ranks, like first, second, third. You might see things like president or vice president or secretary. Another thing you might see is different types of presents or gifts or rewards. Okay? In combination, that is when order doesn't matter at all. This is when you see things without rank. There is no rank, or you have the same gifts or no ranks, or you're talking about food. Okay, so in food, order doesn't matter. Okay, so please make sure that you are practicing this. Again, your homework lets you attempt each problem twice. Your practice test lets you attempt it 6 times. And then when you take the final test, you only have 1 chance for each problem. So please make sure that you're doing that. Also, I recommend that you take the practice test and then come to my help class on Thursday, and then we can prepare you for by going through the practice test. After you're done, you can take the test. So you'll have Thursday and Friday to take the test, and you'll have, reviewed with me things you need to know. So I strongly recommend that's what you do. Please do not wait until the last minute to do all this work. And if you have any questions, make sure you reach out.